Bismillahirrahmanirrahim. Assalamu alaikum everyone, dear students. Hope all of you are doing well. Welcome once again to our regular chemistry first paper online class English version arranged by KPB School and College. This is Irene Parvin. Dear students, we were discussing chapter 3. Today, I will discuss hybridization of orbitals and coordinate covalent bond in this chapter. The title of chapter 3 is Periodic Properties of Elements and Chemical Bonds. Before learning about hybridization, you have to know the necessity of hybridization. We can we can know about the shape of molecules and ions and bond stability of them, and we also can know about bond formation and shape of compounds or molecules by hybridization. Now, what is hybridization? The process of mixing different orbitals of different energies to form same number of orbitals with equivalent energies in valence shell of an atom during reaction is called orbital hybridization. The new atomic orbitals formed are called hybrid orbitals. Here you have to pay attention to some certain words like different orbitals. When the orbitals are mixed, they have two different orbitals, and definitely they have different energies, and these orbitals is present in valence shell, and when new orbitals are formed, they have equal energies and equal number of hybrid orbitals are formed. For example, beryllium, the valence shell of beryllium is 2, and here two different orbital s and p mix together and produce fully new two sp orbitals. That means two orbital mix, and after that they will form two new orbitals. And for example, a boron, here the valence shell of boron is second shell, and here one s orbital and two p orbital px and py mixed together. That means here three orbitals mixed together and form newly three sp2 orbitals. And for carbon, the valence shell is also 2, and here one s orbital and 3p orbital, that is px, py, and pz mixed together, and after mixing they form 4 sp3 orbital which have equal energy. Now I would like to discuss different types of hybrid orbitals. Depending on the types of pure atomic orbitals like s, p, d orbitals and their numbers taking place in hybridization, different types of hybrid orbitals are produced. That means typing of hybrid orbitals depend on their pure orbitals and number of orbitals, such as sp3 hybridization, such as sp3 hybridization, sp2 hybridization, sp hybridization, sp2d hybridization, etc. That means there are different types of hybrid orbitals. Now, I am going to discuss sp3 hybridization. The process the process of formation of four equivalent orbitals by mixing and equalizing of one's orbital and equalizing of one s orbital and three p orbitals of an atom is known as sp3 hybridization. And in this case, here in look at the figure please. Here uh, in this case, one electron of 2s orbital, one electron of 2s orbital enters into 2p jet orbitals during excited state of carbon. One electron of 2s orbital enters into the 2p jet orbital, and 2s orbital and 2s orbital and 3p orbitals. 3p orbital means px, py, and pz are combined together to form four identical and equal energetic sp3 orbitals. Here, four sp3 orbitals. I repeat it again. In the excited state of carbon, one electron of 2s orbital enters into 2p jet orbitals, and the valence, you have already known that the valence shell of carbon is second shell, and one, uh, one electron of 2s orbital enters into 2p jet orbital. Then 2s orbital and 3p orbital, that is px, py, and pz orbital, are combined together to form four identical and equal energetic sp3 orbital. For example, formation of methane. Look at this figure. Formation of methane. Here, carbon with sp3 orbitals combined with one s orbital of four atoms to give methane. That means carbon with sp3 orbitals, four sp3 orbitals. This one, this one, this one, and this one. These four sp3 orbitals is combined with one s orbital of hydrogen. Every sp3 orbitals combined with uh, one s orbital of hydrogen and form four sigma bond, four sigma bond with hydrogen, and this is the structure of methane molecule. And the tetrahedral arrangement is favored because it allows sp3 hybrid orbital to stay as far away from each other as possible, and thereby reducing the electron repulsion. The angle between any two orbitals is the angle between any two orbitals is 109 degree 8 minute. Now I would like to discuss about sp2 hybridization. The process by which one spherical s orbital and two dumbbell p orbitals combined together to form three new identical trigonal planar orbitals is known as sp2 hybridization. That means in sp2 hybridization, one s orbital and two p orbital is present and they mix one another and produce three sp2 hybrid orbitals. Look here, here uh, the one one electron in excited condition of carbon, the one electron of 2s orbital enters into 2p orbital and 2s orbital and 2p orbital, that is px and py. One s orbital, one s orbital and 2p orbital px and py orbital are combined together to form three identical and equal energetic sp2 orbital. This three sp2 orbital and spz orbital remains in unhybridized state. Look here, this spz orbital remains in unhybridized state and of the three sp2 orbital contains each contains one electron. The angle between any pair of orbital is 120. The angle between any pair of orbital, that is the angle is 120 degree. For example, the formation of the formation of ethene molecule. Look at the figure, please. In case of ethene, sp2 hybridization of carbon occurs. Each carbon contains three sp2 orbitals. Look here, each carbon contains three, 1, 2, 3, and this carbon also contains 1, 2, 3 sp2 hybrid orbitals. One sp2 orbital of each carbon atom overlaps head to head and forms sigma bond. One sp2 orbital of each atom, that means here this one and this one overlap head to head and form uh, sigma bond. The rest two sp2 orbitals, the rest two sp2 orbitals of each carbon overlap head to head with one s orbital of hydrogen. Here this one and this one, these two sp2 orbital of first carbon form sigma bond with two hydrogen atom and and second carbon also the and second in second carbon 2sp2 orbital form two sigma bonds with two hydrogen atoms. That means this one and this one. Now, uh, each carbon contains one hybridized pz orbital. Pz orbital which forms one bond by lateral or sidewise overlapping. Each carbon contains one pz orbital. First carbon, this one is first carbon, and this pz orbital is for second carbon. And now these two pz orbital overlap sidewise overlapping and form pi bond. Thus, in ethylene molecule, double bond is formed. One is sigma bond and another one is pi bond. One is sigma bond and another one is pi bond. That is carbon carbon double bond is present in ethene molecule. Next, I would like to discuss sp hybridization. When one s orbital and one p orbital, if an atom mix together and equalize to produce two new equivalent orbitals, that means their energy will be equal, then the process is known as sp hybridization. In excited state of carbon, one electron of 2s orbital enters into the pz orbital, and here 2s orbital and one 2p orbital, that means px orbital. Here one s orbital, here look at the figure please. Here one s orbital and one p orbital, that is px orbital, combine together and form two hybridized bond, two sp hybridized bond. Here this one and this one, and uh, here the other 2p orbital, that is py and pz, are left in unhybridized condition. This py orbital and pz orbital left in unhybridized condition. In this case, sp orbital lie in a straight line. Look here, please, attention, please. In this figure, two sp hybrid orbital lie in a straight line. These two hybrid orbital, these two sp hybrid orbital lie in a single straight line, and the angle between the two sp orbital is thus 180. The angle between two sp orbital is 180 degree. The unhybridized 2py and 2px orbital are in right angles to the line of the sp hybrid orbital. That means unhybridized uh, 2py and 2pz uh, orbital are in right angle with hybrid sp orbital, that is right angle. This one is right angle with uh, sp hybrid orbital. For example, formation of ethane molecule. Look at the figure please. Formation of ethane molecule. Ethane means C2H2 molecule. In case of ethyne molecule, it has two carbons and each carbon contains two sp hybrid orbitals. Each carbon contains two sp hybrid orbitals. One sp hybrid orbital of each carbon overlaps head to head with each other and forms a sigma bond. One sp hybrid orbital of each carbon overlap each other head to head and form one sigma. These two sp hybrid orbital overlap each other and form one sigma bond. Other sp hybrid orbital of each carbon overlaps head to head with s orbital of hydrogen atom. This one overlap with hydrogen atom and this sp orbital is overlap also with hydrogen atom. Now unhybridized sp unhybridized 2p orbital of each carbon overlaps laterally or side to side or sidewise and form a pi bond. Look here, the 2p orbital of this carbon and 2p orbital of another carbon overlap side to side and form pi bond, side to side and form pi bond. Now another 2p orbital of each carbon overlaps sidewise and forms another pi bond. Look here, this pz orbital overlap with another pz orbital of another carbon and form another pi bond. This thus carbon 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 triple bond is created. One is sigma bond and other two is pi bond. Next, I would like to discuss coordinate covalent bond. Coordinate covalent bond when one atom in a compound contributes one pair of electrons. Please give attention, please. One atom in a compound contributes one pair. One atom, that means one atom gives one pair of electrons and the other atom without contributing any electron share this pair with the first atom to form a covalent bond, and then this type of covalent bond formation is known as coordinate covalent bond or simply coordinate bond. If I we give an example, then this is very clear to you. For example, formation of ammonium ion. Here, ammonia molecules, look at the figure please. Here ammonia molecules with its lone pair electrons, here this pair is lone pair electrons, combines with proton or hydrogen ion. This is proton or hydrogen ion and it has no electron. To form ammonium ion by coordinate bond. Look here, this sharing electron comes from nitrogen, only from nitrogen. Since hydrogen ion has no electron, so this sharing pair of electron comes from nitrogen atom, and we can express this type of bond by arrow sign. Look here, we can express this type of bond by arrow sign, and the difference between coordinate covalent bond and covalent bond is in coordinate covalent bond, sharing pair comes from only one atom, and in covalent bond, sharing pair electron comes from both atoms. I think this class is helpful for you, and uh, you have understand understood everything. Now your homework is uh, prepare 20 MCQ from today's lesson. No more today. Stay safe. Take care. Bye.